Welcome to ITIL Practices Part 2 module. By the end of this module, you'll be able to recall the purpose of IT asset management, service configuration management, release management, deployment management, monitoring and event management, and information security management. You'll be able to recall the terms IT asset, configuration item, event. The purpose of IT asset management is to plan and manage the full life cycle of all IT assets, to help the organization maximize value, control costs, manage risks, support decision-making about purchase, reuse and retirement of assets, and meet regulatory and contractual requirements. The definition of an IT asset is on the screen now. Remember, this is one of a list of terms that is included in the syllabus that you may need to recall in the ITIL Foundation exam. An IT asset is any financially valuable component that can contribute to the delivery of an IT product or service. Asset management is a long-established practice that exists outside of ITIL. It includes the acquisition, operation, care and disposal of organizational assets. IT asset management, or ITAM, is a sub-practice that is specifically aimed at managing the life cycle and total cost of IT assets, including equipment, software, and infrastructure. Software asset management is usually regarded as an aspect of ITAM, specifically aimed at managing software assets. When implementing IT asset management, it will be necessary, therefore, to consider how it will be integrated with the organization's general asset management practices, responsibilities, and tools. The definition of an IT asset as something that is financially valuable implies that there will be a financial threshold below which a component will not be included in the scope of IT asset management. The life cycle of each asset type that is in scope should be clearly defined, stretching potentially from the planning and procurement of an individual item to its retirement and ultimately disposal. In each case, it must be clear when and how the asset details will be captured and recorded in the IT asset register. Good interfaces with the processes that change the status of assets, such as change enablement, deployment management, and incident management, is essential for capturing the information in the IT asset register and keeping it up to date. Regular audits are important also, both to maintain the accuracy of the information held and potentially identify unrecorded assets. For most organizations, investment in IT assets represents a significant portion of overall spending. IT asset management ensures that the organization obtains full value from this investment by providing visibility of assets to support good decision-making about purchase or reuse of assets, understanding the cost and value of individual assets and, therefore, the true cost and value of products and services, protection of IT assets from theft, damage, or misuse, compliance with legislation and regulations, for example, in relation to disposal of hardware assets. The next practice is service configuration management. The purpose of service configuration management is to ensure that accurate and reliable information about the configuration of services and the configuration items or CIs that support them is available when and where it is needed. This includes information on how CIs are configured and the relationships between them. The definition of a CI is on the screen now. This is another one of those terms you may need to recall in the ITIL Foundation exam. A configuration item is any component that needs to be managed in order to deliver an IT service. Configuration management systems can quickly become very large and costly to maintain. So, when deciding which components will be managed as CIs and what attributes or information will be held for each, a double test should be applied. Can this information be kept up to date? Does the value this information provides outweigh the cost of maintaining it? IT asset management and service configuration management are similar practices in many ways and will benefit from close integration. So, what is the difference? All IT components above a certain financial value should be treated as IT assets, as described previously. This enables the organization to track and trace these assets in order to ensure that it gets maximum value from them and protects them from misuse, loss, or damage throughout their life cycle. Service configuration management provides an organization with deeper insight into how IT components are actually used and configured to build and deliver services to customers. Not all IT assets will necessarily be managed as configuration items, and not all configuration items will necessarily be recorded as IT assets. On screen, you can see a simplified service configuration model, which represents visually the level of clarity and understanding that organizations seek to achieve through service configuration management. The module shows all of the components, including hardware, software, buildings, people, suppliers, etc., that make up a specific service and the relationships between them. A relationship could be a physical connection, for example, between two network devices, or between a computer and the software components installed on it. Or a logical relationship, such as between a laptop and the user it is assigned to. Many other practices are able to use this information to good effect. A service desk analyst, for example, responding to a user report of an incident, is able to more quickly and accurately assess the true impact of an individual component failure when they can see which services this component supports and what other components may be affected. While configuration information may be centralized in a single configuration management database, or CMDB, it is more likely for it to be held in various locations across the organization, resulting in multiple CMDBs. For example, the networks team may hold and maintain network configuration data, while data center staff may have tools with which they configure and store information about servers and databases. It is important to consider how these CMDBs can be connected to provide a joined-up view so that people can see the full set of information they need. A configuration management system, or CMS, is the broader term which describes the complete set of tools used to capture, store, connect, and use configuration data. A CMS may contain one or many CMDBs. The next practice to be considered is release management. The purpose of release management is to make new and changed services and features available for use. It was the ancient Greek philosopher Heraclitus who said that the only constant in life is change. The pace of change in modern business is frenetic and only ever seems to increase, leading to huge pressures on IT service providers to make new services and features available frequently and quickly. A release can be very small, for example, a minor change to a single component, or it can be very large, involving hardware, software, documentation, training, updated processes and tools. In either case, the release represents a moment of risk and must be appropriately planned, scheduled and managed. A release plan will specify the exact combination of new and changed components to be made available and the timing for their release within a broader release schedule. The release management and deployment management practices are closely linked, and organizations should define a high-level approach to how these practices will work together. This may vary depending on the nature of the service or the service relationship. In some environments, for example, all of the release management work takes place before deployment, with plans in place as to how exactly which components will be deployed in a particular release. The new functionality becomes available as the release is deployed. This is the traditional model of release and deployment that many people working in IT will be familiar with. For example, a major service release is rolled out over a weekend to be available to users when they return to work on Monday morning. The only release activity to be completed after deployment is the post-implementation review, which is always necessary to enable learning and improvement and help ensure that customers are satisfied. On the other hand, in an agile or DevOps environment, software and infrastructure are typically deployed in many small increments, often throughout the day. These changes are deployed into the live environment, but do not become visible or available to users until release management enables the functionality. The purpose of deployment management is to move new or changed hardware, software, documentation, processes, or any other component to live environments. It may also be involved in deploying components to other environments for testing or staging. Although a separate practice, deployment management works closely with release management and change enablement. The success of a release depends upon the integrity of the release being maintained as it moves between the development, testing, and live environment. Alignment of the deployment to change and release requirements, including key aspects such as schedule and cost, must be managed effectively. Communication around deployments is part of release management. Individual deployments are not generally of interest to users and customers until they're actually released. The purpose of monitoring and event management is to systematically observe services and service components, and record and report selected changes of state identified as events. The key to understanding this practice is to understand the definition of an event, the third key term included in the exam syllabus. An event is defined as any change of state that has significance for the management of a configuration item or IT service. The key word in this sentence is significance. A typical IT infrastructure consists of a very large number of hardware devices supporting an even larger number of software components. These components generate a huge amount of messages during a processing day, the majority of which do not require any acknowledgement or action. They are essentially system chatter. Every now and then, however, a message indicates a change of state that does have some level of significance and should therefore be treated as an event. The purpose of monitoring and event management is to monitor for these messages and, when they occur, recognize them as events and take appropriate action. Clearly, in most cases, it would not be feasible or the best use of anyone's time to use individuals to sit and sift through the entirety of a system's output messages looking for the significant ones. This should, therefore, be a highly automated practice. Monitoring and event management requirements should be a key consideration during the design and testing of any new service, so that when the service goes live, monitoring systems are able to detect those changes of state that are defined as events, determine their significance, and initiate the appropriate control action. Event types fall into three broad categories. Informational events typically indicate normal operation. They do not require immediate attention or action. They are simply captured and retained for later use. Informational events provide an audit trail. For example, evidence that a user logged into a system or that a scheduled task completed successfully. They also provide the data for regularly scheduled reporting or trend analysis. For example, service response times, device utilization over time. Warning events indicate that something unusual has happened and needs to be considered. Typically, warning events are flagged to the appropriate team or tool so that, if necessary, action can be taken to avoid any impact on service. For example, a networked device is starting to report an unusual pattern of activity, or resource utilization is within 10% of a defined threshold. Exception events indicate that an exception to regular operation is occurring. Typically, something has failed or is running in a degraded state and is either having an impact on service or is likely to. Exception events require action. For example, a server is down. A device has exceeded its recommended maximum utilization. A PC scan reveals the installation of unauthorized software. This practice is highly interactive with other practices. Exception events, for example, typically will trigger incident management and, potentially, problem management. Warning events, for example, may indicate potential performance issues that require a response from capacity management, change enablement, and other practices. Informational event data will be used by many other practices. The last in this group of practices is information security management. The purpose of this practice is to protect the information needed by the organization to conduct its business. This includes understanding and managing risks to the confidentiality, integrity, and availability of the organization's information. CIA, of course, is a useful mnemonic to help remember the purpose of a practice which is focused on security. Confidentiality means that data, objects, and resources are protected from unauthorized viewing and other access. Integrity means that data is protected from unauthorized changes to ensure that it is reliable and correct. Availability means that authorized users have access to the systems and the resources they need. An organization's data is one of its most valuable assets, so the practice of information security management must be driven from the most senior levels in the organization and be based on clearly understood governance requirements and organizational policies. The outputs from the practice include the security policies and plans, processes and procedures, and physical controls that protect the organization's data from theft, corruption, and loss. To many people, information security management immediately conjures up images of external hackers trying to illegally access data by breaking through firewalls or fraudulently obtaining login details. And this is, indeed, a huge risk for many organizations. However, the internal risks arising from the malicious, accidental, or just plain foolish things that staff do can be just as great. Everyone in the organization, including potentially consumers, suppliers, and partners, has a responsibility to comply with the security policies and processes. Regular security awareness training should help staff understand why the policies are important and understand their responsibility to recognize risks and take the appropriate actions. It is also important to achieve balance. Information security controls that are too restrictive may do more harm than good. Consider a simple example. An organization decides to reduce the risks to data CIA by tightening its password policy, requiring that from this point on, passwords will be a minimum of 10 characters and must include alphabetic, numerical, and special characters. It also requires that passwords are changed regularly, and users are prohibited from ever reusing the same password. It is likely that the outcome of this change of policy will be the opposite of what was intended. Risk actually increases as users, finding they are having difficulty remembering their passwords, resort to writing them on post-it notes which they hide under their keyboards.